Okay guys, we're going to be covering two sections in this video. We're going to do 8.4 and 8.5, and the good news about this is it's mostly vocabulary in these two sections, so hopefully it won't be anything too crazy for you. Alright, let's start with this first one here. A polynomial is a monomial or sum or difference of monomials. Okay, so remember from the last section, a monomial is something like x squared y. Alright, it's one term, even though it might have x's and y's in it. And then the polynomial with the sum or difference, meaning we might add on a z, maybe we subtract an x cubed. So we're going to start adding little pieces. So this would consist of 1, 2, 3 monomials, but together it makes a polynomial. Poly just meaning many. Okay, now if we talk about the degree of a monomial, it's the sum, so addition, of all the exponents of its variables. Okay, so take a look at number 1 example down here. If I look at the exponent on m, it's a 1. The exponent on n is a 2. And the definition of degree means the sum of the two. So I would say that this monomial, 5mn squared, the degree is 3. So you add up the exponents, that's the degree of a monomial. Alright, the next one, the degree of a polynomial. Okay, so now you're taking many monomials and putting them together. The degree of a polynomial is the greatest degree of any one term in the polynomial. Okay, take a look at example 2 here. If you look at the first term, add up the exponents, x squared, y squared, so 2 plus 2 makes 4. That would be the degree of that first one. Take a look at the next one, 3x squared, the degree would be 2. Alright, now the last one's kind of tricky. The 5, it doesn't really have any x's, so it has degree 0. Then you're looking at your numbers, and you're choosing the greatest degree. So I don't add them up or anything, I just say the degree is 4. Okay? Alright, let's look at number 3. So the degree of the first one, 1. The degree of the second, 2, because I add the a to the first, b to the first, 1 makes 2. The degree of the next one would be a 3. The degree of the last one would be a 0. And then you choose the greatest one. So for this case, it would be 3. So your task when you're doing some of these is to find the degree of a polynomial and then arrange them. Sometimes we'll rearrange them in what we call ascending order. Ascending like smallest to biggest. Ascending a flight of stairs means you start at the bottom and go to the top. The other is the reverse, descending order in the next chunk. So you start with the biggest degree and go down to the smallest. So really all you're doing with numbers 4 through 7 is you're rearranging the terms so that the powers of x, okay, so this is a little bit different, only x, don't worry about any y's or a's or b's or anything that's in the problem, arranging the powers of x so either they go to smallest to biggest or biggest to smallest. So let's take number 4 for example. If I take this polynomial and I rearrange it so that the powers of x are in ascending order, the smallest power of x for number 4 is actually the negative 11. Because for that one it would be x to the 0 power, so I'm not going to write that. Then the next biggest power would be the 7x squared, and it's a positive, so I'll put a plus between them. And then the highest power is 2x to the 4th. So again, you're just rearranging terms. We're not solving, we're not doing anything, just rearranging. Alright, number 5, a little bit trickier on number 5, because here's the deal. We only want to look at powers of x. So if I'm looking at number 5, the power of x here is 1. The power of x here is 0. X here is 3. And x here is 2. Don't worry about the y's or anything else. So if I rearrange it in ascending order, I'm going to go with this. Y squared first because there's no x's there. Then I'm going to go with the 2xy cubed. So even though the y is cubed, don't worry about it, only looking at the x's here. Then I'm going to go with the minus 3x squared y, and then the 5x cubed on the end. Okay, so once again, don't worry about any y's. Okay, so here's what I want you guys to do then. You guys fill in 6 and 7. Now what you're doing is the reverse of what we just did. Instead of going from powers low to high, you're going to go high to low. Alright, give that a shot. Okay, so now what we're doing is we're going to take the area of some shaded figures. In other words, a big area minus a small area will give us whatever's left over. So if we look at this first problem here, what we really have going on is we have a rectangle on the outside, so look at the big figure, minus the inside, which is a circle. And if I'm looking at this, we do need to know all our formulas. We need to know the area of a rectangle is base times height. The area of a circle is pi r squared. So if I'm looking at this and I do the base times height of the rectangle, I can see it's labeled base B, but the height isn't labeled. And I'm going to label it as 2r. Because if r is halfway across, 2r would be all the way across. So it's b times 2r for the rectangle minus pi r squared for the circle. And really there's not a whole lot you do, so I'm going to write that as 2br minus pi r squared. And that's the formula for the shaded region. Alright, let's try one more, and then I'll have you guys try the other one on your own. Okay, let's look at number 10 here. What we've got now is we've got a rectangle on the outside, and then we've got 4 little squares on the inside. So look at the outside. If I do a base times height because it's a rectangle, I'm going to say it's a times b for the rectangle minus 4 times, each square is x by x, so I'm going to call it x squared. And I have a's and b's and x's. I can't combine anything. That's my final answer. All right, I want you guys to try number 9 on your own. The last question on here, number 11, it's something I want to show you on your calculators. So please make sure you come to class the next day with your calculator so I can show you this question. All right, section 8.5, adding and subtracting polynomials. Now, here's the good news. It's nothing crazy. It's nothing we haven't already done. It just might look a little more complex. For instance, if you take a look at number 4, that looks like a crazy mess going on there. Now, let me just start with 1 and 2. When you're adding and subtracting polynomials, all you can do is combine like terms. So if I'm looking at number 1 and I look at the like terms I have 3x squared can join negative 7x squared. Okay, so let's think about it. What's 3x squared minus 7x squared? That would be negative 4x squared. Okay, so x squareds can join other x squareds. Then if I look, I have negative 4x and positive 2x. Those are like terms. That becomes negative 2x. And then the last one I have on there, I have an 8 and a negative 5. Those are like terms. They join and make 3. So that's my final answer. So again, you're simply combining like terms. All right, let's take a look at the crazy number 4 that I circled. All right, what can we combine? We can combine 3a minus 4a minus 3a. So if I do that, 3a minus 4a is negative 1a. Negative 1a minus 3a more is negative 4a. Okay. Then let's do the next one. If I combine my b's, I have 2b and 6b. That makes 8b. 8b minus 2b, back to 6b again. All right. And then let's do the c's. Negative 7c plus 9c is 2c. And 2c minus 7c is a negative 9c. Nope, I did that wrong, didn't I? 2c minus 7c is negative 5c. Okay, so you're simply combining like terms. All right? Now, something you do want to be careful of. Take a look, let's pick maybe number 7. This one has a subtraction between the two terms, so you do have to make sure you do one of two things. Maybe we want to go ahead and distribute the negative to everything. So if I were to rewrite the second part, I would write negative 2x squared plus 9x minus 4. Then start combining like terms. So 4x squared minus 2x squared, that would be 2x squared. My x cubed out here all by itself, it's just going to stay by itself. There's nothing else it can join. Then if I look at my x's, negative 7x plus 9x is 2x. And then negative 2 minus 4 is negative 6. All right, so you're combining like terms all the way. So please take a few minutes, fill in all of those adding and subtracting ones that we didn't do, but I do want to do one of these examples with you down here with perimeter. Okay, here's what you have to remember about perimeter. You have to remember That perimeter is going to be the whole distance around the triangle or square or whatever we're talking about. So when I give you a perimeter, that means all the way around that triangle is 7x plus 3y. Okay? And then you're trying to find the third side. Now, your third side is still going to have x's and y's in it, so don't think you're going to find the third side to be 10 centimeters or 12 or whatever it is. It's still going to have x's and y's for these questions. So if I told you that the perimeter equaled side number 1 plus side number 2 plus side number 3, that would be kind of a nice way to start this one. So then what I'm going to say is they've given me a perimeter of 7x plus 3y. Okay? And they've given me 2 out of 3 sides. So what if I did this? I'm going to call side 1 x minus 2y. I'm going to call side 2 2x plus 3y. And then I don't really know what side 3 is, so I'm just going to call it S3 for now. And what I'm trying to solve for is that S3, meaning get the S3 by itself. So here we go. All we're doing is combining like terms. Let's leave the left side alone for now. Let's combine the like terms on the right. Okay, and we still have this little S3 hanging out by itself. Then I'm going to start moving things left and right. So if I move the x's, I get 4x. All right, so I subtracted 3x from each side. And let's do the same thing with y's. So if I subtract a y over, my third side length ends up being 4x plus 2y, and that's our answer. Okay, so now you guys can finish the last one.